done this. This is probably review. We might have even reviewed this a tiny bit at the beginning of the year. But let's focus on solving absolute value equations and inequalities. Okay, and I'm going to show you a way to think about this so you can not just remember it as facts that you'll forget, but think of it in terms of some concepts that you'll always be able to hang on to, right? Look at some graphs and kind of think about it in terms of what an absolute value function looks like, right? Attach the strategies for solving equations and inequalities to the graph. So first of all, let's just review. Here's what an absolute value parent graph looks like, right? And we all know that. It's just it's just a V with a vertex at the origin. The right leg of the V has a slope of +1. The left leg has a slope of -1, right? So something that's important for us to think about here, just to kind of conceptualize, and it's, you know this, but as far as the distance I move to the right, so whatever my x value is also going to be my y value, isn't it? If I go over by 3, I go up by 3. If I go over by 1,000,000, I go up by 1,000,000, right? So then how do we go about solving an absolute value equation? Okay, so if we've got something like the absolute value of some stuff equals a number. Yes, sir. I am recording. Thank you for asking. You're doing your job. Good job. So I'm going to introduce the idea here also, something that we've touched on a little bit, of a variable substitution, getting you ready for calculus. We do this a lot in calculus. So let's let U really just represents so U is just some function of x. Could be anything, right? Some function of x. At this level, it's not going to be anything horribly complicated. We're not going to do sines and cosines and trig functions. We're just going to do linear equations. So something of the form ax plus b or mx plus b. Maybe at some point we'll throw in a little quadratic or something too. But it's just some function of x. And rather than have to make this look too jumbled up and messy, we're just going to call it U for now. So we're just focusing on the absolute value part of this. But you get what I mean by it's just some function of x. So for example, we could have something like, if I have something like the absolute value of -3x plus 7 is equal to 17, well, we'll just make the substitution. We'll just call that U, right? But really what it means is just good enough. Really what it means is -3x plus 7, right? So we're making the variable substitution, in other words. Let's let U equal -3x plus 7. And then it looks a lot simpler, doesn't it? Then we just end up with the absolute value of U equals 17, which looks a lot easier to solve. Eventually, we're probably going to go back and reverse the substitution and plug the -3x plus 7 back in when it's convenient, right? We don't always have to do this, but for now it makes it easier to think about the process. Okay, so let's look at that graph then. If the absolute value of U is equal to A, then what does that mean? Now, think about this in terms of the stuff we've already done, right? We've done some examples where we've solved things by cheating. We've solved things legally cheating, by graphing things, right? What's legally cheating? Legally cheating if we have technology available, right? If you were going to solve the equation, let's say I gave you a really difficult equation to solve, and I told you, you got to solve this on the next test, but you have technology available. So I want you to solve e to the sine squared of log x equals 1. Can you do that? Not yet, probably, right? You will be able to. Probably can't do that now, but we could do it on technology, right? With technology, it'd be easy. What would we do on Desmos? Yeah, okay, so if this is the left side, step 1 in Desmos would just be, I'm just going to set y equal to e to the sine squared of log x and graph it, right? Step 2 in Desmos, line 2 would just be y equals 2, and then we'll just look for the intersections of those, right?
2.
I mean, 1.
2 is twice as
Oh, my brain does when I do stuff like that, I'm not sure. But anyway.
You wrote the 2 right there.
Oh, that's it. You got it. Okay, you got it. Should be a psychology major. So we get this, right, so all we'd have to do is look for the intersections of the blue and the red graphs, and that would, whatever those x coordinates are, those would be my solutions, right? Okay, we've always got that strategy, right? So let's apply that here. Well, the graph of the absolute value of u just looks like a v, doesn't it? Right? If I go over by u, I go up by u, right? What does the graph of y equals a look like? A is just a number, just a horizontal line with the y-intercept of a, right? So here's, I guess that must be a for this example. It's like 5 point something. But more importantly, this is the line y equals a, right? And this is the graph. Y equals absolute value of u, right? And we're just intersecting those two things. Okay, well, where are the intersections going to be? There and there, right? When we go over by a, and we'll go up by a, and so we will be at a point that has the same y coordinate as that line. Do you get that? Okay, does that make sense? If this is the line y equals a, well, for this value to cross it, it needs to have a y coordinate of a. Just so happens, though, because it's a v, because it's an absolute value function, the x coordinate, or the u coordinate in this case, is a, right? If I go back the other way, in order to have a y coordinate of a, I've got to go back horizontally a distance of negative a, right? And so what's that tell us then? That tells us that if we solve that absolute value equation, the absolute value of u equals a, we get two answers. We get one of them over here at negative a, and one of them over here at positive a, right? And so we always know then that this starting equation, right, this absolute value equation, always is going to lead to these solutions, either u equals negative a or u equals positive a, right? Okay, and so we can always make that conclusion. So let's try an example of one of these then. So what about this guy? What are we going to do first? Yeah, so we've got our, let me borrow this thing again. Right, we've got a u in there. It's the wrong size though, isn't it? So we've got a u in there that we can just ignore what's inside, but we've got to make that look like the absolute value of u equals a number, right? So the first step is always going to be in solving an absolute value equation. And this is, give me, real quick, how comfortable are you with solving absolute value equations? Give me a 5 if you like are completely, like, I get this, I already know everything about this. 1 meaning I know very little about this. Where are we on the scale? Okay.
I don't know.
Okay, maybe you haven't. Maybe you haven't. Okay.
I think we did the
Okay. Okay, I mean, it's possible you did this now. I mean, I would think maybe now is for one you did, but you might not have too, so that's fine. But I want to go over it anyway. So the first step is going to be, we've got to isolate the absolute value, right? So don't touch anything inside the absolute value function. That's off limits, right? We're just going to get the absolute value by itself. So what's that amount to? I mean, obviously, we're just going to, what are we going to do first? Add 2, and then divide by 4. Okay, good. And so then now that we've isolated the absolute value, we can go back to, right, to this concept. If the absolute value of something, absolute value of u, or in calculus a lot of times we say the absolute value of hand, meaning we don't even know what's back there, is equal to a, then either hand equals negative a or hand equals positive a, right? Probably better to use a u. In textbooks, they'll use a u.
Why not a hand?
It's too hard to draw, I guess, you know. So then what's the next step? Yeah, u equals negative 10 or u equals positive 10. And now we can kind of take the blindfold off, and what's behind the u? Well, what was the u? I forgot. Negative 2x minus 6, right? So, well, I guess I kind of skipped some steps there, didn't I? So we get that, and that, right? And so now, what are the steps to solve in both cases? Well, I'm just going to, in both cases, don't I just add 6 and divide by negative 2? So if I add 6 here, I get negative 4. If I add 6 here, I get positive 16. If I divide by negative 2, I get those two answers. Okay, how can I check it? Plug them in. Yeah, plug them in, see if it works. So if I plug a 2 into my original equation, does it work? So negative 2 times 2 is minus 6. Negative 10, absolute value of negative 10? 10 times 4, minus 2. Check. What if I try, what was the other one? Negative
8.
Negative 8.
Yes, sir.
So negative 2 times negative 8, positive 16 minus 6, 10, absolute value of 10. Well, what do you know? We're right back. The rest is the same, right? Okay. So we got it. So what about one like that? Okay, just quickly try that. Everybody, get out your notes and just scratch that one out. Okay, let's take a look. Let's take a look here. So, what are we going to do first? Subtract 11. So we're isolating absolute value, which we can forget about that stuff for now, right? So what are the two steps in order to get the absolute value by itself? Subtract 11 and divide by 2. Okay, good. So that'll give us, if we do that, won't we get absolute value of 2x minus 20 equals what? 68, right? Divided by 2, so 34. Everybody agree? Now what?
2x minus 20 equals 34 or negative.
Easy, right? And then what are the two steps in order in both cases? Add 20 and divide by 2. So what do we get? 27 or what? Negative. Oh, sorry. 14. Negative 14.
17. Oh, wait. Oh, right.
Right? And then divide by 2. Is that what you got? Okay. Good. I must have done it. You must have done it right then. Must have just done it. Must have looked weird.
Yeah, I don't really know what I did.
but it doesn't look like that, but I have the right answers.
You probably did something, I mean, you must have, I don't think you'd get it right if you didn't do it right on that one. I think you must have done it right. You just must look different.
Yeah.
Okay, how about this one?
Yeah.
Let's take a quick look at this one together. So, once again, we're gonna isolate, right, so we can ignore what's inside. What are the two steps in order? Add 11, and then divide by 2. So if I add 11, what do I get? 0. What's 0 divided by 2?
0.
So I end up with the absolute value of u. 3x plus 6 equals 0. So now, what happens now? I only get one equation, don't I? Yeah, because there is no negative 0 is just 0, right? There is no negative or positive 0. 0 has no sign. And so in this case, I only get one equation coming out of this, which is 3x plus 6 equals 0. So what's my solution? If I subtract 6 and divide by 3, I just get a single answer, x equals negative 2. So where must the intersection have been then? If I go back to that graph. In this case, yeah, it makes sense that we set the absolute value equal to 0, so we were intersecting it with the line y equals 0, which is the x-axis. And so the intersection occurred at the one point, which is the vertex, right? Okay. How about that one? We'll go through this together, and you tell me when we can stop. So what do I do first? Add 1 and divide by 3. So that's going to give me the absolute value of 2x minus 1 is equal to negative 6 divided by 3 is, what's the answer going to be? This one is actually, I get why you'd say that, but this one is actually no solution, right? There is no solution on this one, okay? And why is there no solution? Okay, so in the context of the graph, if we're going to use the graph as the model, the horizontal line would have been below, completely below the absolute value function, below the vertex, and so there's obviously no intersection. We can kind of reason through this one, though, just by thinking about the context of an absolute value function, right? The behavior of an absolute value function. If I have the absolute value of something is equal to negative 2, well, that makes no sense. What does the output of an absolute value function always have to be? Well, so how do we say positive or 0? Really?
Greater than
Integers. There's a word for that, non-negative.
Non-negative.
Okay. Non-negative is how we'd say that in math. Non-negative means 0 or positive. How do we say 0 or negative? Non-positive. There you go. Okay.
Could you, you had us do,
Mhm.
I got like.
Oh, look at
So on what? That one? That one?
Yeah.
So what'd you, ask your question again.
So does the absolute value just mention negative 20?
Oh, no, it doesn't, right? So that's a good question, right? So this comes up a lot. So the absolute value of negative 4 is what? 4, okay. But what's the absolute value of 2x minus 20? The absolute value of 2x minus 20. We can't change everything in there because if I did that, it would change the function, right? I'll give you an example. When we evaluate this thing, if I pick an x value, now let's say I pick x equals 0. If x equals 0, 2 times 0 minus 20 is negative 20, right? What's the absolute value of negative 20? Okay. What if I pick 1? If I let x equal 1, what is 2 times 1 minus 20? Negative 18, you said, right? Absolute value is positive 18. So the absolute value part of that, when I input a 1, I should get an 18 out, right? But what if I did say, oh, okay, well, let's just make everything positive because it's absolute value. Look what would happen. Then when this became a plus sign, it would change my answer, right? When I put in a 1, I'd get a 22 instead of an 18, right? So we can't do that. You can only, now you can apply an absolute value to a number. You just can't apply it to a variable because the variable represents all numbers, including negatives, right? So by the same token, when we did, I thought we did one with a negative in there, so that one, right? I can't make the -2 and the -6 positive, even though that's a -2x, doesn't matter, right? Because I've got a variable in there. And so the value I'm inputting into the absolute value function, just because those are negative signs, doesn't mean it's negative. What if I input a -1,000? Then I'm gonna get -2 times -1,000 is 2,000 minus 6 is a huge positive number, right? You get my drift? Okay? All right, so what about this? Now let's look at a different situation. Now we've got the absolute value of something, some function, is less than or equal to. We'll just do less than or equal to. But even if the equal to sign weren't there, it would be the same concept, right? Some number. Okay, well, what does that mean? The absolute value function, that's giving me y values, right? If I want y values that are less than or equal to the line y equals a, and here's the line, the boundary line, y equals a, then wouldn't that be all the entire part of the xy plane that's below that line? We want to look for the intersection of this shaded region, right? Because if I want all the values less than that line, there's an infinite number of places on the plane where that happens. It's everything below the boundary line for infinity, right? Well, where in that infinite region does that intersect with our v? It intersects with our v in that part right there, doesn't it? Right? So what we need to do is we need to isolate, though, we're trying to solve for x, aren't we, in these equations. So we want to know what's the interval of x values where the red v intersects with the region below the line y equals a. Does it make sense that it's everywhere between that point and that point? Yes. Everybody agree? So if I were to take that part of the v and squeeze it onto the x-axis, wouldn't I get that interval right there? Right? And let's remind ourselves real quick, what are the coordinates of those points? Well, this one we know that this is the line y equals a, so we must have gone to the right by a, right? We know, once again, that the y coordinate here is a, so we must have gone to the left by a, right? And so that tells us then, if we just focus on that one part, there's our interval. Doesn't that tell us that that's the solution? If I were to look at just the x-axis, how would I say that? Okay, but so you start with u, though. So u is what? How do I say that interval? U is greater than or equal to -a and, what do you know? There it is right there, right? Okay? So there's our general conclusion we can make. If we isolate an absolute value inequality where it's a less than inequality, right? Where the absolute value of u is less than or equal to a, it is always, always, always going to lead to that outcome, right? Every time. And all we have to do then is solve that inequality. Now, solving inequalities is a little bit trickier than solving equations, so let's go through a couple examples of that. Okay, let's try one. So what about this guy? What are we going to do? Okay, so first thing we're going to do is we're going to isolate, we're going to ignore what's inside the absolute value and isolate the absolute value, right? Now, we got to remind ourselves, though, this involves some algebra of absolute values, right? What are our basic rules of absolute values? I mean, they work almost the same. Algebra with absolute, or not absolute values, inequalities. Algebra with inequalities works almost the same as it does with equal signs, right? There's only just a couple exceptions. If I divide by a negative or multiply by a negative, I got to flip the inequality sign, right? That's really the only thing we have to worry about. We got to be careful. So what are the steps in order to isolate the absolute value here? Okay, so we're going to add 1 and divide by 2, so I get the absolute value of u right, is less than, if I add 1, I get 6. Positive 6 divided by positive 2 is 3. Did I ever divide by a negative? So I don't have to switch the inequality. And now we can pull the curtain back and see what we got inside. 3x plus 9. Okay, because I've got the absolute value of u is less than 3, what kind of a compound inequality does that translate into? And you see, let's just backtrack one step really quick. Do you see the value of this? When we went from the absolute value of u is less than or equal to a to this compound inequality, that opened doors for us, right? Because we can't do regular algebra with an absolute value function in there. Absolute values are really hard to do math with if you leave them written as absolute values. Algebra gets very complicated. There's lots of rules you have to apply. So our goal is we want to liberate that from the absolute value bars. We want to get rid of the absolute value inequality and replace it with a regular old inequality where we know how to deal with it, right? Where all our rules of algebra are simple, okay? I get that we're trading, you might be thinking we're trading a single inequality for a double compound inequality, but so what? It's still well worth it. We want to get rid of the absolute value bars and rewrite it without them. So how do we do that here? What do we do with u? U is what? Sounds like bad grammar. U is what? Greater than and less than positive 3, right? Okay, and we know what's in the middle. That's just a 3x plus 9. So now, and we did practice this. I know we did this because I purposely reviewed this at the start of the year to kind of get ready for this stuff later on. So what are the steps now? How do we deal with solving a compound inequality like that? Subtract 9 where? Everywhere. Good. So we subtract 9. So then that gives us, in the middle, we get 3x. Here we get what? Negative 12. And here we get negative 6. Now what? Divide by 3. So that gives us x, negative 4, negative 2, right? That's our answer. Okay. Make sense? Okay. Yep.
Do you have to put it in a compound inequality before you do the simplifying part, or?
You do. You do. The question is, I think, could you do the simplifying up here?
Yes.
You can't. Because, here's why. Because what would you do to simplify it? You'd have to subtract 9 from everything, right? But subtracting 9 from an absolute value function, that's not easy to do. Right? That's very complicated because the absolute value function, so this, I'll say this, if this doesn't make perfect sense, don't panic because it probably should. But here's how I would explain this to like a college calculus class. I would say that the reason you can't do this is because an absolute value function is defined as a piecewise function. And so you can't look at it, you have to look at it in discrete pieces, right? Technically, you guys are advanced, I'll just show you this, but if you don't panic if this doesn't make sense. Technically, here's how you would define the absolute value. The absolute value of u is equal to positive u when u is positive, negative u when u is negative, and 0 when u is 0, which really makes sense. You guys will get that if you think about it for a second. If I plug a 7 into an absolute value function, what's the answer? 7. I don't do anything to it. If I plug in a negative 7, what do I get? 7, because it's negative, I've got to multiply it by negative 1 to get its opposite, right? So because I have to define this thing as a piecewise function, where the domain is broken into separate parts, you can't do regular algebra on it. Okay, so you have to break it into a compound inequality first. Okay? Long answer to a short question, but there it is. Good question. Okay, so what about something like, oh, I got that written wrong, didn't I? Should have been this. right? What if u is greater than or equal, absolute value of u is greater than or equal to a? Okay, what about this one? Now, wouldn't you agree that if I'm looking at all the values in the xy plane that are greater than or equal to a, the value a, let me do this actually. I think I got this, trying to mess that up. Okay, I sort of did. Let's. I want to fix this for your notes. We're just going to look at just a regular inequality this time, okay? Okay, so if we want the value, we want to find the intersection of the absolute value of u and the region where y is greater than a. Well, greater than a, we want to know where the function is greater than a. Doesn't that mean where its y value is above the horizontal line, y equals a? Everybody agree? So we're looking for that region. Where does the function, where does the y value, where's the y value greater than the line y equals a? Because there's the line. Y equals a, right there, right? Okay, well, where does that happen? Well, that's going to happen up here on this tail of the function and this tail of the function, right? So it's going to start at that point, and then it goes forever, right? As the absolute value function rises to the left, it's always in that region. Starting at this point, as it rises to the right, it's always in that region, okay? So if we're looking, we want to find just the x values where that's happening. Wouldn't that be out here and out there, right? Everybody get that? Okay, so anytime you have a function like that, an absolute value, isolated absolute value function is greater than a number, you can always make the trade. I gotta fix that again, all right. You can always make the trade, that trade, right? We're only going to pick the values that are less than that point, which is negative a, and greater than that point, which is positive a. So it just looks like that, doesn't it? U is less than negative a, or u is greater than positive a, every time. You can always make that trade. You start there, you end there, right? So let's try that. How about something like that? Okay, so first, we're just going to isolate the absolute value, right? Ignore what's inside. What's the one step to isolate the absolute value? Add 6. Okay, if I add 6, I get the absolute value of u is greater than 24. Okay, well, what's inside? Negative 3x plus 21. Okay, so what's that tell me then? What's the compound inequality I can trade that for?
Negative 3x plus 21 is greater than
Negative. Okay, so either that's going to be greater than positive 24, or that's going to be less than negative 24, right? Okay, so let's just do the algebra on that. So what are the two steps to get that by itself? Subtract 21. So I get negative 3x is greater than 3. Now what? Ah, there we go. Good. Divided by negative 3, which means I have to flip the symbol. I get x and I get negative 1. On this side, I go through the same steps. So negative 3x is less than negative 45. Divide by negative 3, and I x is less than positive 15? Or greater than, sorry, I gotta flip it, don't I? Whoops. Right, and because I've got that negative, I've gotta flip that around, whoops. Flip that around and get 15. I don't know why I got rid of it, but you get the idea, right?
You got it.
Okay, make sense? Okay, what if, hypothetically, what if I did all this work and I got an answer like this? What if I got an answer like x is, what if I got an answer like x is less than negative 4 or x is greater than negative 10?
It's just a small.
Now let's graph that real quick. I want you to see, this is rare, but it can happen. So here's negative 10, there's negative 4, right? So this one, if I graph x is greater than negative 4, or less than negative 4, doesn't that look like that? X is greater than negative 10, doesn't that look like that? So what part of the x-axis is shaded? All of it, right? So that answer would actually be all reals. Okay, make sense? Okay. All right, that's a lot of math. Friday football, oh yeah, Friday football fun. Yes.